In this chapter, we are going to talk about the fundamental unit of CPU utilization, which is threads. And also, thread is the basis of multi-threading computer systems. So in particular, we are going to talk about what is a thread and what is the relationship between process and thread. And we are going to talk about the thread-enabled multi-core programming and also talk about a multi-threading model that are usually used by operating system to support different threads. At last, we will talk about the thread library and how to use the thread in Linux C programming. Nowadays, most of the user programs are multi-threaded. There, the application supports multiple tasks, and each task is implemented by separate threads. So for example, the most commonly used application, Microsoft Word. So when you tap the keyboard to input the letters, there is a task to update the display and show the letters on the screen. And also, there's another task to fetch data on the background. So especially, so you open a very larger file, the entire file cannot be loaded into the main memory. So when you scroll up or scroll down to watch other part of the file, the task can help us fetch data from a hard disk. And also, one task will check the spelling while you type in some letters. So just like Google Gmail upgrades its interface, so the new interface support very good spell checking functionalities. And also you can add a URL into the text. So when you click the URL, another task will answer a network request and fetch the URL content and show them on the web browser. So then you can see that all those tasks, they are implemented within a single application. And nowadays, those tasks can be implemented by separate threads. For the aforementioned Microsoft Word example, so we can have one thread to update a display, one thread fetch data, and one thread do spelling checking, and one thread answer a network request. Then you may ask, okay, Dr. Wang, so previously you have mentioned the multi-processes. So for example, the Google Chrome use multi-processes to implement the tabs. So why do we need a multi-threaded processing? Nowadays, more and more applications tend to be implemented with multi-threading instead of multi-processing. The reason is because process creation and maintenance is a heavyweight. However, the thread creation and maintenance is lightweight. So in later slide, when we go through the details of the thread, so you will know that the reason why thread creation and maintenance is lightweight. Then sometimes we want to use a multi-threading instead of a multi-processing. And also, according to our observation, we found that for most of the tasks within an application, so they may share the similar or even identical context or behaviors across different threads. So when you are using multi-threading, it can simplify the code and increase the efficiency. And also, later you will see that the communication between multi-threads is much more easier and simpler compared with the communication between the multi-processes. So that's another reason why multi-threading can simplify the code and increase the efficiency. And nowadays, instead of using multi-processing into the kernel of our operating system, the kernels are generally multi-threaded because it's more simpler, less bugs, more secure, and also more efficient. In this slide, we are going to compare the traditional single process with the multi-threaded process. The single process can also be called single thread process. On the left side of this slide shows you the single thread process. So as we have discussed in the previous chapter, the PCB, do you guys remember the PCB? Process control block of a process include the binary code, global variables, and the initial data, I/O, and heap. And also we have a program counter to remember the next instruction will be put into the CPU, and the registers to record the status of the thread. And also the stack, which is used to temporarily store the function parameters and the local variables. So here you can see the clear boundary. For the code, data, file, and heap, they belongs to the process. For the registers, program counter, and the stack, they are belongs to the single thread. So that's why the single process can be deemed as a single thread process. So here we only have one copy of a program counter, register, and stack for single thread. So in this kind of a process, if you want to implement a new similar task, so you need to duplicate the entire process, which include the same code, data, files, heap, program counter, registers, and stack. On the other hand, on the right side of this slide shows you the multi-thread process. So you can see that they have the same structure. For code, data, files, and heap, they belong to process. So those parts do not need to be duplicated in multi-threaded processes because they can be shared among different threads. So when you want to implement a new task, you only need to add a space for CPU registers, program counter, and stack for the new thread. According to these two versions of processes, so you may know that why multi-threaded process is lightweight and more simpler compared with the multi-process. Another advantage of a multi-threaded process is that, so since each thread has its own program counter and registers, so that each thread can be put into the CPU core, right? However, for the single threaded process, since only has one program counter and registers, so only one CPU core can be used. So even though you have multiple CPUs in your computer, then you may ask that, so since we have multiple threads within one process, so how can we distinguish them? It is very similar to the multi-process structure. So within the PCB of each process, we have a unique process ID to distinguish each process from others. For multi-threaded process, the similar idea has been applied. So within each thread, beside the program counter, stack, and registers, it also has a unique thread ID that can be used to distinguish from other threads. And also, since multiple threads share the same data structure within the process, so the communication among threads are much more simpler compared to multi-processes. So it doesn't like the multi-processing communication, which is relying on a shared memory or message passing to achieve the communication. Next, let's use a web server as an example to further demonstrate the power of multi-threading. So if we design a web server with a traditional single thread process, so there we only have one thread inside the process, and only one thread can be executed in the CPU to do one task at a CPU time instance. So even though there are multiple users wants to communicate with this server, the server can only serve one user's request at a time, right? So other users, they must be wait there. Then you can imagine if the server is quite popular, so maybe thousands of users send a request to this server. If serve one user will take 1 second, then you can do a calculation. So how long it will take to serve a user in worst case. It will take a thousandth of a second. So definitely it is unacceptable. Then someone may ask that, okay, Dr. Wang, so we can use a multi-processing model to implement this server. It can serve multiple users at the same time. So surely we can do that. However, due to the process creation is a heavy weight. So when we create a process, may take hundreds of milliseconds or even second. And also, since each process has its own binary code, global variable, initial value, heap, or I/O, it means each process will occupy more system resources. So however, the total resources of a server is fixed. So suppose we can create 1,000 of processes at a time to use up all the resources of a web server. Then we can serve 1,000 of users at a time with a multi-processing model, right? So since the task of each process in web server is to serve user request, so all the processes have the similar behavior. So which means those processes, they have the similar or even identical binary code and data structure. So in this situation, why we duplicate the binary code and the data structure? So actually we can use the threads to serve those user requests. And multiple threads can share the same binary code, global variable, initial value, heap, and I/O there. So which can greatly save the resources occupied by each thread and increase the efficiency there. And also, since the lightweight of a thread, the creation time for each thread is dramatically shrinked as well. So to create a thread, maybe only need a tenth of a millisecond. So with the same resources of a web server as the multi-processing model has, so maybe more than 10,000 of threads can be created at the same time. It means more than 10,000 of user requests can be served at the same time with the multi-threading model. So down below show you guys the real solution as a multi-threading web server. So inside the server, one thread listens the new request from the user. So when the new request has been accepted, a new lightweight and more efficient thread will be created to serve the new user request. So this multi-threaded web server can achieve the best performance compared to the single thread process. So even the multi-processing model. This slide shows you the benefits for using multi-threading. So compared to single-threaded process, the multi-threading process can provide better responsiveness. So which means if part of the process is blocked, the remaining part of the process or other threads can be continually executed. So for example, within the process, one thread is updating the display. And when user taps in something into the computer, it can immediately reflect on the screen. So while another thread is dealing with the I/O, so even though the I/O thread may be blocked, so it won't affect the thread who updates the display. So however, if a single thread process, so when the single thread is dealing with the I/O, the whole process will be blocked and nothing will be updated on the screen. So when the user taps in something into the computer, it can make the user feel really weird, right? So compared to multi-processing model, the multi-threading can provide a better resource sharing because the threads inherently share resources of a process, so such as binary code, global variable, initial data, heap, and I/O. So which means they can already share resources with each other and do communication with each other easier compared with the multi-processing model. And also, compared to multi-processing model, the multi-threading can provide a better economy because the thread creation and switching are much cheaper than the process creation and switching, as we already mentioned in the previous slide. And compared to single-thread process, the multi-threading model can provide a better scalability there. So especially nowadays, so there are multiple CPUs inside the computer and more cores in each CPU. So when the multi-threading model has been used, each thread can be executed inside a core. The parallel computing can be applied to further improve the efficiency. However, with a single thread process, so no matter how advanced the computer can be, no matter how many CPUs or cores you have, the single thread can only occupy one core. So for all other remaining CPUs and cores will be wasted and idle there.